Hey everyone, hope my voice is good, should be audible. Hey everyone, hope my voice is good, should be audible. I think it should be Hey good, everyone, hope my good, voice is audible. Good, let should me double check. I think it should be Hey good, everyone, hope my good, voice is audible. Good, let me double check. I think just double checking the voice once. If double checking the voice once. Yeah, I think there is no background. Cool. So I'll get started. Yeah, the idea is simple. We'll tackle weekly contest 358 today, and we'll do this stream and we'll see how many problems we are able to solve or not. Most probably two or maybe more than that, right? So let's go. So you are given an integer nums and you have to find the maximum sum of a pair of numbers from such that largest digit in both the nums is so you are given an integer nums. You have to find the maximum sum of pairs such that the largest digit in both is equal. Okay. So 2, 3 made if it's where 7 is the largest among them return. You have to find the maximum sum of a pair of numbers. Okay. So two pairs is the largest is same, right? In this largest is different than all of these. In this largest, so basically I can compare it with all the numbers I can see, right? And then in the end I have to return the largest, right? Largest here is this, here is, and yeah, so basically brute force we can do. So 4 is equal to, just give me a second. So we'll get started. So 10 is equal to less than and I plus plus, and then for it j is equal to 0, j less than j plus plus, j will be I plus 1, right? So let's call it a, that is nums dot I, and then we'll call it b, that is nums dot j, right? And we need to find the max, right? So max and max is equal to, let's say, 0, and max is also 0, while a is while a is not equal to 0, and so basically what we can do is max a is equal to max a comma a mod 10, a is equal to a by 10. Same thing we need to do for b also. Will be max b, max b, b, max b, max b. Second. And this also b, right? b, b. If max a is equal to max b, in both of the places it is 0, right? And number is greater than, so it will never be just 0, right? So then max is equal to max of max uh, nums of I plus nums of j, right? And into max is equal to minus return. Should have not taken this much time. So minus 1590288. Have taken way a long time than expected. But yeah, still it's okay. Okay. Double a number represented as a linked list. Okay, so you were given a head of an empty linked list. So basically given 189 and you want to double it. Basically you want to 189, right? So one way is that I can create a list and then yeah, that is I think the way. So right, and then I have to return a list, right? So what I can do is list node head 2 is equal to list node uh, this right, and while list node current is equal to new list node is equal to head, right? If head if is equal to null, current 2 is uh, equal to null, current is not equal to null, list node new node is equal to new, or maybe instead of doing this way, right? Instead of creating another list, I can do it in much simpler way. So if head is equal to null, you return null. Now while head is not equal to null, right? Not null. So list integer list is equal to new list, right? While and then I need this. Basically, then it is like adding two lists, but in the end I have to return a node also, right? So I'm going to save the above one. That is going to be my node. So list node current is equal to new head while current is not equal to null. List dot add current dot value. Current is equal to current dot next. Right? Next. Now he basically now my all the values are there in the list, right? Now what I'm going to do is while current is not equal to now starts the list part, right? And we have to we are given what we are given is head representing so nine basically nine, nine so nine ten, carry one, right? So this again will be then carry one, so it will just come there. So we have to return that head. So basically list is starting from the end. So can I do it in that way? But here we only have a next pointer, right? I will have to reverse that. Yeah, that I can do probably. So we'll do a reverse of it later. So we'll find. So basically then we'll have to reverse it now only, right? Yeah. So we'll reverse it. So previous is not current is equal to not equal to list not next is equal. So current next previous is equal to, and this current dot next is equal to previous is equal to current, and current is equal to next. So basically what I did is 1 pointed to 9 and then 8 points to 8, and yeah, so it is not null, then it makes sense. So yeah, this is it. Current dot next is equal to previous. That is fine. Yes, that is fine. So now my head is pointing to 9, right? So now list. So let's change the head also. Head is equal to previous, right? Now here I don't need to do this current. So while current is while current is not equal to null, I go back. I go while current is, so now comes the, and I also haven't carry is 0. Now you are at 9, and J is also. Or do I really need to create this part also? Because it is the same number, right? I can just, oh, I don't need all this also. So let's get rid of, you just need your current and you just need your previous. So once you have done that, right? So it is like sum is equal to current dot value plus current dot value, right? Plus carry, that is the sum. Now you have to do that is equal to sum modulo 10, right? Or modulo 10, yeah. And then carry will be, carry is equal to by 10, right? While carry is not equal to 0. Now that is the case, right? And then your, once you do this, right, you can also say current is equal to, current is equal to current next. If carry is not equal to 0, then current dot next equal to this node carry, right? Current is equal to current dot next. So there it would be null, right? So you would reach basically next of ones. So you would need previous because, yeah, so you would need a previous is equal to current previous. So here one previous dot next would be that previous is equal to previous dot next. Now once you have got this, you will reverse it again. So current is equal to previous to is equal to null. Current is not equal to previous. node next is equal to current previous to next is equal to previous to is equal to current, and current is equal to next, return previous to. So this is how it would be. This is not needed. Let's see, previous to, let's see, to define this node date. Okay, so let's see what we did, right? So current will be null, right? Yes, current will be null. So so current is equal to head, because new head we have current, and this is 2. Okay, so head is equal to previous. This is all fine, right? And current, while current is not equal to head, so you corrected current dot value is equal to previous is equal to current, current is equal to current next. To print what is the value system dot current, current value should be 991 at least 862 something else only is coming. Current value, so 9989 carry is 0, right? So it should be 8. Now it is 9. So it should be 8, 8, 6. Then it is 8. Yeah, then you carry. And that is some pattern. No pattern. So then I think it will be 837, right? Now here your carry is not equal to 0. So what you did, you said your okay previous dot next is equal to less dot array, and that is your previous dot next. Then after that you said that okay, you need to reverse it. So you said okay, my head is this. Yeah, 378, right? 198. Let's submit it. Cool. So that's how took me more time than I should have taken, but still. So you are given a zero index and integer x. Find the minimum absolute difference between two elements that are x indexes apart. So in other words, find the minimum absolute difference. Minimum absolute. What color is it? Okay, let's make it red. Glitter is also there. But let's make it red and white. So basically, you were given a 0, 3, 2, 4. That also and you are also given x, right? Find the minimum absolute difference between two elements. So minimum absolute difference between two elements in the array that are x indexes apart. So 0, 1, 2, 3. 2. Okay. So basically, the difference should be minimized, but they should be at least x distance apart, right? And we need to minimize it. Feels like a sliding window. Why? Because 4, 3, 2, 4, 0, 1, 2, 3, right? So this will only become a candidate when you are at least two distance apart, right? At least x distance apart. So till this is not even a candidate for this, right? This will be valid for this. But do we really need, right? Uh, is there a mechanism that I can decide among 4, 3 which would be more better for 4? That's the question here. Constraints would be 10 is to power 5, I think. And so, so basically, for every number, all the numbers for 4, all the numbers that come after x are candidates. For 3, all the numbers that come after that are candidates, right? So if I increase this, right, and then so for this, all the numbers here and here are candidates. But I need one that is closest to 2, right? Because we need to minimize the distance. Now, how would I get that is closest? Sorting is not here because it will disturb everything. I do. Maybe we can brute force it. Mhm. Okay, let's think again. We minimum distance apart. So if let's say 3 to 10, 15 is and then 0, 1, 3 is the then here x is 2 for this x is 2. So there should be minimum 2 gap, right? So so for this, this, right? So it is 5 to 15, right? Sort that also I don't need to sort, I need the one that is a minimum value. So if let's say start with 5 and then I reach a limit that okay this is x distance part, right? 5, 3, this is not x distance part. Now I reach a limit that is x distance part. To which element? To this 5, right? It is x distance part to this 5. So the maximum is 3 as of now. Now will this 5 be of any use? Yes, if 6 is here, right? It could be of use, right? So it could be of use. 6 is there. Then what I can do? Can't slide the window also saying that okay 5 is dead. Can't do that also. I think I'll have to. Where are we? The rank. Very. What what would be the answer here? LinkedList and greedy. So probably it is not. this. Mhm. Given time, right? Yeah, okay, I think I will give it one. Find the minimum absolute between two elements. But let's check the rating of this one. Thing is solvable. Yeah, I'm not getting any clue, guys. Just see once. Mhm. This discussion will see really the not to question three. 'Cause this guy is good. Use a sorted set as for any index. Look for very good. Suggestions for fourth. This is this is no, this is pure consistency, but why he still at a question? Why is nine Samsung IoT Rockwood? In done. Let's only consider the cases where I is less than J. So they are saying that okay, just think of this way. Don't think of this. For index J, we are interested in an index for interested for index j. We are interested in an index j comma minus x, like for j2 0, j3 these two, this and this. Yeah, okay. That minimizes. Okay, they are saying that for this to find what minimizes, for this to find what minimizes, for this 15 find what minimizes. That will be sorted. So for entry while going from left to right. Okay, so sorted set. While for every index j, j minus x. So j is 0, which is none. For this 2, we will add 5, right? Then for this 3, we will add 3, 5. Okay. After this, we can calculate the closest value to nums of j. Okay, that is true. Okay. So you'll do binary search was there. Well, let's see Java per bound. So in the tree, you start from x itself, whatever is the x, 0, 1, 2. But why are considering 5? It will be automatically considered, right? Yeah, good. This guy works at time. Tomorrow. Where does this one stand? Guardian. Oh, nice. Good. Okay, so I think this is a good question. Why we don't need to get for 2, 5? Why we don't need to get for 15? Because for this it will be automatically calculated. Okay, guys, let's Mhm.